Now understand about embedded system. So this is like a casual definition, but let's understand what is this through this slide. Okay, here if you see, imagine you have a thermometer that automatically turns on a fan when it gets hot. Imagine that. So the thermometer would turn on when it is a thermometer would make the fan turn on when the thermometer is hot, right? So it feels hot, so there is a small computer, it would decide to turn on the fan. The whole system is called as the embedded system. That is a small computer part. This whole system is known as a embedded system, and the small computer part here is called as the MCU, that is a microcontroller unit. The thermometer plus fan connection is the embedded IO. So that means when the thermometer becomes heats, the fan is getting on. That is embedded IO. And which does this is this microcontroller unit here. That is MCU. So this microcontroller unit is like a tiny computer or a single chip that you can say that has everything built in it itself. Okay, it's like a small computer or a single chip. That is, this microcontroller has its own processor, its own RAM, storage, peripheral device, all in this tiny chip. It's like a small computer. So to understand this, a computer system is built around this microcontroller unit, which contains a microprocessor with lot of peripherals designed to control interaction with the physical environment. That means in the physical environment, some things, maybe a bulb, you are switching on something, a bulb, for that you are switching on the switch. So that's an interaction which is done in the physical environment. So with this, what happened with this, the bulb has to glow. Okay, so that is done using this microcontroller unit, that is MCU chip, which is there. Okay, so here if you see, like this thermometer is a what? Thermometer is a microprocessor, and this fan is a peripheral device. So through this microprocessors and peripheral devices, there is this combining them. What does combine them? The small computer, that is a microcontroller unit. So this can combine a microprocessors with peripherals. So it is used to control the interaction with our physical environment. So the defining characteristic is that the end user is often unaware that a computer is inside. We just see only that we are clicking on the button and we see the fan is on. We doesn't know that there is a small computer between them which actually do this work. We doesn't know, we are just seeing the output only. Okay, so that is what you can say from this. What do we mean by embedded system? This whole system is called as the embedded system. Okay, and this thermometer and the fan is the embedded IO, and the small computer here is a microcontroller unit. So embedded IO system, the subsystem responsible for managing the communication between the microprocessor and the physical world. It handles the real-time task in domains like IoT, that is Internet of Things, automotive and industrial automation, through three main building blocks: sensors, actuators and communication interface. So you have to understand this subsystem, which is responsible for managing the communication with this processor and the physical world. The subsystem managing this communication between them are known as the embedded IO system, right? Now it handles this embedded IO system, that is the complete embedded IO system is which managing this communication between this processor and the outside world, right? So this can basically has three main building blocks in this embedded IO system. We can have the sensors, actuators and communication interfaces there between them. Let's understand the four key components which is there. There is input device, output device, communication interface and processing core. Let's understand input device. Like input device would be what? The like temperature sensor which detects the temperature, sensors, switches, keyboard which is collecting data, right? So analog to digital bridge, that is analog to digital converters, bridge the gap between this real world analog signals like temperature and pressure and the digital processor. We know there is analog to digital converters, that is real world analog signals are there that has to be converted to the how the digital processor can understand. So this ADCs are there to bridge this gap between this analog and the digital processor. Analog signals are the temperature, pressure that we are measuring through the sensor, through the switch, or through the keyboard. We will collect the data, and that data would be in the form of analog signals. So to build this gap, we have ADCs, that is analog to digital converters, that can bridge the gap between these signals and the processor. Now output devices are actuators, displays, and DACs. That means actuators are the motors. Display, you have LED, LCD display to show whether LED is light on or something like that. Displays are there. Yeah, actuators are what? Actuators are the motors. Now we have the DACs. Now we have DACs, that is digital to analog converters. That is, after you get that output, how you have to see in the analog form itself. So there is DAC, that is digital to analog converters, is also there in the output device. So this system would act so to get it in the physical world. So there are displays and actuators and displays for seeing the output. These are the output devices. So there are input devices like sensors, switches, and the keyboards, and these have this analog to digital converters. Now output devices are there, that is actuators, displays, and all. That is digital to analog converters are also present in this. Actuators include the motors and all. Now there should be a communication interface that is needed here. That is, for component to component communication, for serial communication and all, you have UART, 12C, and SPI. Now parallel interface, for high speed data transfer, we have parallel interface. So for component to component communication, you have these. We will discuss what is UART in our syllabus. We have to learn very detailedly. The serial protocol is the parallel interfaces. A parallel is high speed. Parallel interface is a high speed data transferring. Serial protocol is component to component communication. What is UART? UART, SPI, all these is there in our syllabus to clearly learn. Again, a processing core. The MCU, or this microprocessor, is the heart which is there, often running on a real-time operating system to manage task scheduling and minimizing latency. Now there is a processing core, that is the main part. The heart of the system is this microprocessor or MCU. This is running on the real-time operating system, that is RTOS. It is often running an RTOS, real-time operating system. So this is what managing the task scheduling and minimizing the latency is done here. That is a processing core. Okay, so this processing core is doing the scheduling work, the latency minimizing, all this main thing is done by this processing core. So the core idea you have to know that what is happening in this embedded system is that the sensors will sense, that is input, and convert into digital signals, right? And the processor, that is this MCU, which is running, which can often run as a real-time operating system, can processes it, and then we can see the output using this output device. There's a communication between the components which can be serial protocol as well as parallel interface can be done. Understood? That is what you have to understand. So this is just a thing. This is something more depthly. If you understand each concept, you can understand here. That is input device. Input device is like which is collecting the information from the world is done by this input device, like temperature sensor which feels the heat, the switch or the button which feels the touch, keyboard feels typing. So the problem here is that these are analog signals. So you have to, computer can understand only digital signals. So this ADC converters would convert this analog to the digital, like how the computer understand. This we have understood about input devices, like sensors are there, switches are there, keyboard is there. Now output devices is like things that do something based on the computer decision, like what the computer decide, that can be shown in the output device. That can be the actuators, that is what we have said, motors. Displays are LED, LCD, speaker which make sound. So the computer can speak only digital, but we can understand only analog signal, or the device can understand. Device needs what? These devices need analog signals. So these digital signals has to be, that is the computer's digital signals are converted to this analog signals which is understood by the device, and for the real world purpose is done by this DAC, that is digital analog converter. Now there are a lot of communication interference, how different chip or component can communicate with each other. You have different type, UART, 12C, SBI, and PIO is a parallel. These are serial, this is PIO is a parallel interface. So how this is done, the speed and all we will discuss later. So this part just understand that. UART, different communication interface are there. Now processing core is the brain or the heart that basically does all the thing. MCU would receive the input and will process it, and then it will send the output. So it is like a real-time operating system. Normal OS takes its time. You wait, RTOs react instantly. That is, normal OS would have temperature and all. When you're sensing, it has to react very instantly, right? It cannot take time, so the temperature would change if it takes time, right? So normal OS would take time, but our real-time operating system, this processing core has this real-time operating system in it. It can react instantly without any delay, because in airbag system, when there is crash happen, then real-time operating system must react in milliseconds. Then only that bag can come in the car, right? Otherwise, like normal OS would take too slow. And what is the purpose of airbag system if it is too slow? So normal OS cannot do the work. We need real-time operating system which can react instantly. Understood? Thank you. This is the main here we have just given an introduction to embedded IO system. What is microprocessor? What is the components here? The input, the output unit, the communication interface, the processing core. That's it.